I'll start up. My name is Tony Samaritano. I'm one of the technical co-founders of a company called Verge Aero. And what we do is drone light show technologies. We build all of the technologies from top to bottom that enable drone light shows. And then we also do it as a service. So we go out there in the field and we put on shows for larger clients. Some of our shows you might have seen just over the course of the past few years. Usually, like when I start these up, I'll just like get a raise of hands of who's actually seen one in person. But luckily, we have Rob and Uvify who did it last night. So everybody's seen a drone light show, and that's awesome. And please join me in congratulating them. It was a beautiful show last night. Yep. I'll just jump into it. Okay, so I'm gonna try to keep this pretty light and just fun. It's very high level, and really the motivation here is for like myself, so Verge, and just the drone light show industry in general, to kind of go over the high level lessons learned, what we do day to day, and how can we all work together to really like identify and build upon PX4 in the context of drone light shows and drone swarms in general. So while I'm going through this, please like write down questions. We'll definitely have a little time for Q&A. So I'm going to keep it all high level. If you have any technical questions, I can dig in. But what I'll go over today is just like Verge, what makes us different, just some challenges in the context of PX4 and how we are continuously able to deploy these drone light shows successfully and safely, kind of just our workflow as we continue development of the system. And then the meat of this is going to be just behind the scenes and kind of extracting some of the lessons learned and opportunities at the same time. And again, I want everybody to be thinking in the context of, okay, from these lessons learned, what can we do to work together as a community to really improve PX4? Because we're putting tons and tons of resources into flying hundreds of drones very regularly. And then we'll just get into today versus tomorrow, where we see it going, and then open it up to questions. So just real quick on Verge, our mission really as a company is to make this technology accessible. So right now, drone shows are really expensive. We're really just at the high level of the market right now. And we're like in the price category of like 3, 4, 5 times the cost of a comparable fireworks display. Now, you get really cool technology when you get a drone show, and people love it, but bringing that cost down is going to be super important to enabling the market. So that's really our mission as a company. And then for Verge, we do the hardware. So this is our X1 drone. That's just been like our workhorse for the past few years. Then we build all of the ground support, networking, the equipment, the software that runs the GCS. As well as at the highest level, we've created a design software, which is much different than how most people are doing drone shows today. Traditionally what you would do if you want to put on a drone show is you'd fire up your favorite animation studio, so Blender, 3ds Max, Cinema 4D, whatever, and you're programming points in those, assigning colors and using the animation editor's keyframing to move the drones around dynamically. Those then get turned into waypoints with times associated in colors, and that's uploaded to the shows. We've taken a bit of a different approach where instead of essentially programming the individual pixels, what we're doing is we're describing the show. So what we're doing is, you can think of it as like Adobe Premiere. It's kind of like editing a video. What you say is, you fire up like your favorite SVG editor and you draw a shape. So say like you want a heart in the sky or whatever, or a logo, it doesn't matter. You do it in your favorite SVG editor, you import it into the design studio, and then you say, okay, I want 100 drones in this heart shape at this time, and I want, at the same time, I want 300 drones over in this 3D effect, and I want them to be going at the same time. And then you put those all in a timeline and hit render, and all of the path planning and stuff happens behind the scenes in that render. And it comes down to a single file that then gets uploaded to all the drones, and then you do the final checks, and we'll go through that, and you send it off and get your drone show. So it makes designing, it gets the creative tools to designers where they don't need to be a professional 3D animator. They can just go do all this stuff. And it's like pretty easy to pick up and learn and iterate on. So for drone light shows, there's a lot that goes into it. There's a lot of challenges that we have encountered and have overcome. But what I really want to do is just focus on some of the key ones for PX4 and kind of like how we continuously are able to develop this system in the context of the flying portion of the drone shows. So before I go into it, just super basic high-level architecture of what's on the drone. We have a mission computer talking directly to PX4. Our PX4 isn't forked. We're pretty much always at upstream with a few patches on top, so it's almost stock PX4. And a lot of our core IP is sitting on that mission computer. The mission computer is just in off-board mode, sending velocities to PX4. PX4 is executing that. But what that allows, that decoupling, what that allows us to do is iterate really, really quickly on the mission computer side and build new features. And essentially, we're just interfacing with PX4 and allowing it to do what it does well without worrying about breaking PX4. And then we have a series of onboard radios and stuff. Everything is RTK based, etc. Okay, so validation, verification. We're constantly in this development cycle. And the main tools that we use are the CITL, simulation and hardware, leveraged flight tests, and then just general good software practices with continuous integration. So I'll kind of go into this, just our simple cycle here. And there's a lot of opportunity here, we believe, for collaboration with PX4, specifically around flying lots of units, collecting lots of data for analysis when we're trying to push out the next major release, for example. So starting at the top, we do a lot of work on our mission computer, which is decoupled from PX4, which allows us to iterate really quickly, right? So we're constantly pushing firmware out to our fleets with the latest feature that our pilots and people on the ground have identified and want those new features or just general bug fixes. Once we've just passed our CI and everything internally, then we start to move to firing up a lot of CITLs and flying based on known shows that we've done in the past. We know they should be successful, so all of our CITL tests should pass, right? Once that's done, move to simulation and hardware. So this picture in the bottom right-hand corner is pretty common in our engineering facility when we have the drones there. We fire up hundreds of these things, just plug the battery in, turn them into simulation and hardware mode, and run the full system. Just everything besides the sensors. That's the only difference between these. So like by this point, by the time you get to simulation and hardware, you've removed all the bugs during this iteration cycle. We have flown thousands, if not tens of thousands of individual flights in either simulation and hardware on real hardware or in just the general simulations that we can just spin up in the cloud. Then small-scale flight tests, which is like 30 to 50 drones, make sure everything works outside, make sure there's no sensor issues, major sensor issues, large scale, so that's 100 to 200. And then we do an internal deployment where we'll take that code that's been validated, this push, and we'll do it on one of our own internal shows. Once that happens, we're like, okay, green light, that's good, everything checks out, and then we can ship it to our customers. And then we just start the cycle again. So it's that loop over and over again. In this video is my show manager who during test flights likes to just take his shirt off. That's the result of that. So we have a lot of fun during the flight tests. It's a good time. Okay, so analysis and reliability tools. We leverage a lot of what PX4 has already created, both on our mission computer and obviously on PX4. We use the microlog or the ulog format. So we can really leverage what the open source community has already created to do log analysis. The one thing here that we do only on the mission computer side, which I think is a real opportunity for PX4, is to collect all those logs. You need so much bandwidth, and we're not using Wi-Fi. We're using Internet of Things protocols, so it's very low packet rate, low just data rates, but fairly reliable, many drones that we can connect to at the same time. So what we end up doing is when the drones land, we analyze all the logs internally on the drones, then we send a single packet out to like less than 100 bytes that tells us what happened during that show, and if there were any failures or any thresholds that were exceeded, right? So then our pilots can identify those, we pull the logs, and we put them through normal analysis. But I think, especially like when, for example, we were doing the 113 push, is working directly with the community, and we're able to spin up and fly thousands and thousands of flights on this new software. So what I think would be really valuable, other than me going onto the dev call and being like, yeah, it worked for thousands of flights. That's all the feedback you get. Being able to do something like this, some automated post-show log analysis or post-flight log analysis, where we can collect that data, get the critical errors that occur, so we can pull those logs and send them up to the community in some uniform way for additional analysis during verification.
Are you looking at code level errors? What logs are you collecting here?
So yeah, no, I mean that's the case. So like one of the things is like estimator errors. Like you look at the flags. So just parse the ulog file on board, and if flags are high for your velocity or position error, some estimate error, that would be super useful to then pull that drone's log and then take a deeper look at it and try and find the core problem and report that to the community, and we can work together to figure out why that happened, why that occurred.
So these errors are obviously code level errors, but that did not show up.
Right. Yeah, or you just couldn't see it. You didn't know. Like it was caught, or like with 113, you have multi-EKF. So even if there was an estimator error, it might have just happened on this specific IMU, but it's okay. The drone finished the show because its estimators are fine otherwise. So we're missing all of that, right? So that would be super useful, exactly. But it's impossible. We're not going to plug in every single drone after a flight. It's just too much resources to put.
Okay, so,
yeah.
So these drones land.
Yeah.
All these logs that they've collected.
Yeah.
Plugging them. So once they land, they get uploaded automatically to your...
A compressed version of the analysis that's done on board is uploaded per drone.
Because of the protocol.
Yeah, and just because of bandwidth limitations. Yeah, we'd have to leave the drones plugged in for like 24 hours in order to download all the logs over the air, right? So yeah, getting that compressed version that just at least gives you some bit flags that say, hey, there was an error here. You should pull the logs on this drone.
How long does it take once it lands for it to process and...
Oh, it's really quick. Yeah, almost instant. Yeah.
So instead of uploading every log, you actually
on the drone.
The drone itself passes through them. Like these are the 10 things you need to look at.
Exactly. Yeah, and then you have much better visibility. And when we're doing, like one of the examples is on one of the dev calls, like we did PX4 113 validation, and that weekend we just happened to do 1,800 flights. I'm sure there were some errors in there that were just missed. So doing that parsing would be super helpful for both us and the community to find errors earlier, even if the drone's flight was successful, right? Okay, so now I'm going to go into kind of the fun stuff here, kind of the behind the scenes that you don't normally get to see or think about when you see a drone light show. This is kind of a list of the stuff. So the first two, site survey and identify takeoff and landing zone, traditionally that's done before the drones even get shipped to location. The site survey, I'll go into each one of these. Then there's like on-site training. It's very common that we'll only send out 1 or 2 Verge employees who have been trained on the system. And then what you have to do is leverage local labor to work with the system, place the drones, plug the batteries in, charge the batteries. So that's a big part of it. Battery charging sucks. It's really not fun. There's been a lot of talk about smart batteries and how do you manage that. So there is some holy grail in the future where we're leveraging smart batteries. The batteries are managing themselves. In theory, you're just plugging a single AC outlet into a box full of drones, and they're all charging instead of taking XT60 and quad chargers and plugging them all in. It's a real pain. And then we'll get into like what happens before the flight, and then finally just launching the show. So site survey. It depends on the location. We tend to get hired for like larger shows that are technically challenging, so flying in difficult places where GPS is fairly limited, so we have to do a lot. So like on the top left corner here, this every single time we do a show, you have to identify your safety areas. You cannot fly over people due to Part 107 rules, and we wouldn't want to do that anyway. So like identifying and securing perimeters and making sure that like if you need to shut down a street for a show, the cops are there, everything's coordinated with the client. So that's all happening behind the scenes before the drones are even shipped. Sometimes we'll actually have to go and do a site survey. So I'll show a picture there of like what we do in the next slide. But then there's other times where like you just fire up Google Earth and be like, yeah, we could do that. That makes sense. So like, for example, these bottom rows, we flew outside of Lone Depot Park, which is where another MLB, the Miami Marlins, I believe, where they play. And it's just like, we could take off that parking garage. So we didn't have to do the site survey. We just shipped the drones there and then got there a day early just to do some basic validation. So site survey is super important for drone light shows. If you do have to go there, identifying, and once you get on site, identifying and really tuning the takeoff and landing zone is super critical. You need good GPS coverage, so it's placing your base stations in the right place, making sure that there's no magnetic interference on the ground. So like on the picture on the left, that was a site survey that we did somewhere in Chicago. We just needed to make sure that was okay. There's a building right there. A lot of the GPS signals are going to be blocked or reflected from that building, so we just need to make sure that this is a suitable takeoff and landing location. Luckily in this one, the southern sky was completely open, which is a good thing. So that ended up working out for us. The picture on the right, so like when we fly in urban environments, unfortunately some of the only suitable takeoff and landing zones are parking garages. And parking garages are full of iron, just rebar everywhere. Right? So the biggest things that we've learned and the biggest things that block us from like a specific location is GPS blocking obstacles and then magnetic interference. So on the picture on the right is of what we had to do in this particular example is rent a bunch of tables and just elevate the drones off of the surface so that, like if 10% of these take off and start toilet bowling, you're going to get a bunch of collisions or you're going to have a really bad time. So just doing that in that scenario worked out really well. So that's like a big thing with the takeoff and landing zones. Something that you probably didn't think about, or you do, but if you're just flying a single drone, it doesn't really matter. You'll find another spot. When you're laying out 400 drones on a parking garage, it becomes a problem pretty quickly. Okay, so on-site training. It's pretty simple. We'll have our pilots go there, do a quick, like 15-minute briefing with the local labor who have never operated the system before, show them how to charge batteries, how to properly slot, what you should be looking for. Plug the XT60s all the way in. Don't just leave them hanging. Things like that, like very simple stuff. And then the battery charging. So this is one of my pilots, Joel, unfortunately manning what looks like 30-something quad chargers and that many batteries. And it's kind of just a reality of today with our LiPo packs with XT60s. So we'll go into that for the future slides. But it's not fun. Okay, so takeoff and landing zone layout. So at this point, you've charged your batteries, you trained your hands. You're now taking the drones out of the cases and placing them in the takeoff and landing location. So at this point, honestly, it's pretty simple. Just use a tape measure. We did some things pretty early on where like you'd pick up a drone and its light would be red, and then when you moved it over to a starting location, it would turn green, and that's when you put it down. The problem is when you have like untrained hands, they'll pick it up from the top where the GPS is, block the signals. Now the drone doesn't know where it is, and it's just a mess. So what we ended up doing is just the simple thing. Just use some tape measures and lay out the grid. Make sure everything's oriented correctly, and then when you power on all the drones, they're all in their right starting slots. And getting ready for takeoff. Okay, so at this point, now you've laid out your starting grid, and now you plug them all in. So on the left-hand side, all the drones will start connecting, and what you want to see is a sea of green and healthy. But sometimes that doesn't happen. These things are imperfect. So what we've done here in our ground station is it clearly identifies what PX4 is identifying as its current issue. And then, like, for example, we see like gyro failure there or whatever. So that means you right-click on the drone, you say recalibrate gyro, and send it, and it recalibrates. Okay, so that issue's handled. Then you have this red one over here, low battery. Okay, great. the pilot turns off the lights on all the drones, double clicks on that square, that'll light up that drone, and they say, okay, here's a fresh battery, go swap that battery. And somebody will go do that. And the whole goal here is that the pilot is literally in command and just commanding people to go do these tasks. So you're just iterating on that over and over again. One of the things that we commonly do is we have usually a set of sideline drones. So we'll bring like 5% more drones than we need so that when the pilot, if there is an issue that they can't resolve or you're getting too close to showtime, you just pick up a drone, you take that drone out, you put this one in its place, and it's ready to go. So that one's healthy. Now you can resolve the issues with that one later after you've tagged it and reported it. So yeah, it's all about that error detection and getting that done early, and also being able to hot swap drones in. Yeah.
When you're doing that hot swap, how do you make sure that it's swapping for the correct drone? How do you make sure it has, because each one's going to have a different path, obviously?
Great question. Not the case for our system. What we do is that file that's rendered from our design studio, it contains every single flight path for every single slot in the show. And that entire file is uploaded to every single drone. So you can hot swap drones. You don't have to do this whole thing where, okay, I just pulled drone number 34 out and I'm putting this drone in. Okay, 34, you would plug that into, no, there's too much room for human error in that case. So we designed that out from the get-go.
But you still have to reassign the drone that's being placed. You still have to let it know that it is 34.
But that's all automated because with high precision RTK, it knows where it is. So it adopts the slot that it's in. And that's done from the console level. So like if I were to turn off the networking, the drone's not just going to take off and do that slot. The management system needs to say, hey drone, you're in this slot. I see that you're in this slot. I am going to give you slot number 34. So now it knows where to go in that uploaded file to pull the right set of missions and then go fly it. So it's all hot swappable that way and all managed. Like removing human error is our biggest thing. Right, and that's a huge potential. So we designed it out from the beginning.
So in this case, after somebody replaces the drone,
Mm-hmm.
it shows up on your dashboard.
Yeah.
And then you assign it the number.
Yeah, and I wonder if it's in here. Yeah, you could actually see. It's probably pretty difficult, but you see like at the top of each one of those squares, you see drone, and then it says S, and then in brackets, whatever it is. If it's not slotted, it won't have that S and then brackets. It will just say drone and then like an X or something like that to say that it's not slotted. But once it is occupied and you have high accuracy and the console has identified that it's really in that slot and there's no conflictions, then it will assign that one that slot and it'll adopt, in this case, like drone slot 61. And one of the pre-flight checks and one of the things that it's constantly doing as it's querying all the drones is making sure that no two drones have the same slot, because that would obviously cause a confliction, right? So it's all managed, all automatically. Yep. All right, and then the final step is send it. So at this point, you've done all your checks. Your console is all green and healthy. What you do, you arm the system, you turn the safeties off, and then you use whatever you're going to use to trigger the show. So that could be a time code signal. That could just be a manual trigger. You just press the start button. It could be something on like a wall clock. Doesn't matter. You're triggering the system to start. So once the drones are in the air, you're really relying on PX4's ability to identify issues during flight. So if a drone is unhealthy when it arms, it's not going to take off. And that's better than an unhealthy drone flying. So like in all drone shows, you'll see a missing pixel here or there. And that's just the system doing its job. Like obviously we want to get to 100%, but that's pretty difficult to do. So you'll have a missing pixel from once in a while. If the drones are flying and they have noticed that their spatial error, because they know exactly where they're supposed to be at every single point in time at 100 hertz. If they've deviated from that path too long, we'll automatically tell PX4 to land. Just get to the ground. Like do it as fast as possible. So that mitigates a lot of like sensor runoff or like issues where the estimator screws up, you lose global position, and you're just using IMUs to guide yourself down. It's just like get to the ground immediately. That's something that happens automatically. And then in the worst case scenarios where one of the things that we're always trying to optimize is just sharing the airspace with manned aviation. So you always have visual observers, and if a visual observer or the pilot in command notices that there is a helicopter coming in or manned aviation, they have the ability at any point in time to press a button and turn all of the drone's lights on, just flashing red and white. So to just make sure that that pilot can see, oh, there's a lot of, I should deviate. If, and under any circumstances, they don't do that, or you just really need to land, there's always a land all button. And luckily, we've never had to use that in production outside of testing, but like that is an option, which is a problem if you're flying over water. Yeah, it's all about the pre-planning, the coordination beforehand. It's a lot of work goes into a drone show way before you even get on site. Oh, this is the rehearsal from America's Got Talent. That show is like pretty cool. I really liked what the guy, the shirtless guy on that one slide, he designed this. It ended up being really, really sweet show. Okay, so I kind of wanted to go over. I hope everybody's thinking of this like in the context of PX4 and how we can all work together, right? So I just wanted to give a brief overview of kind of the high level how I see this evolving over time. So today, I would say a typical drone show, your average drone show, is anywhere from 200 to 250 drones, which you can do a lot with. You can do some 3D effects. You can do like 2.5D stuff, but primarily what you're ending up doing with 200 to 250 drones is a lot of logos, which is fine because there's a lot of corporate clients who just want their logo in the sky, right? But in the future, we see the average drone show starting to move up to numbers around 600, right? So optimizing these systems and protocols and the technology and the smart battery charging and everything in order to make deploying 600 drones easy and reliable is where we're going to need to be pushing the technology in the next few years. Smart batteries, you know, it just, XT60 dumb LiPo batteries, they really stink. They're just not great. Another big thing is just the move to quad band RTK. So right now, some people have adopted better GPS modules where you're using all of the available constellations. But for the most part, we're still using just dual band, so GPS and GLONASS for RTK. So like in the future, having a better RTK where like if you're in a somewhat GPS compromised environment, at least you're seeing almost twice the amount of satellites. So you have a better opportunity, like if you're flying in a stadium, there's a lot of these walls around you, there could be a lot of reflections, you only have a limited scope to the sky, so when you have more available satellites, that's going to get a better solution overall for the shows and allow us to fly these shows in much more urban and more complex GPS environments. And then logistics, I'm not going to really go into that, it's just kind of obvious. There's like, it's not easy moving these things around, so really working on, you know, when the drones get shipped from our warehouse, the management of those. So like when you ship a box of drones over to site, you know exactly what drones you're getting, you know exactly their status, they've validated themselves, and then just really working to optimize the overall packaging of these things. And again, that's all in the context of trying to improve the economics of this and really try to bring the price of drone shows down to make it wider, make it available more widely. And then like another big thing, automated fleet management. So like right now, you have like very simple stuff implemented. So like in the console or like those post-show reports, all that data is collected and pushed up to a server. But what our clients and what we really need is that no matter what, like you can right-click on a drone, report an issue, it'll automatically check out tickets, things like that. Then our clients who have a drone that needs service, they can just send it back and everything's just automated. So a lot of systems like that are currently in development and I think will really, really help the overall reliability of drone shows in the future. So yeah, it's like a lot of back-end work, not really applicable to PX4, but I think that there is some applicability when you think about it in the context of collecting those logs and giving that critical data that we're constantly generating back to the community so we can solve problems early. And then obviously there's a lot more. But the overall goal of this is to really open up the market and bring the price down so you could see drone shows like you saw yesterday, like all the time. Drone shows are safer, more environmentally friendly. I think they have so much more creative potential than fireworks. So like one of the reasons why you're not seeing fireworks all the time is because of all the complexities and the additional regulations that go around that. Whereas a drone show, you're just dealing with the FAA, and they're very open to this, and they've been a really good partner of ours. And I think that there's so much more market potential for drone shows to be done all the time. So it's really just about bringing that cost down. I think the market is absolutely enormous, and we're kind of just scratching the surface at the moment. So I think that's it. Yeah, so I hope you guys wrote down some questions. I can go into any level of detail. I think we have a decent amount of time. Actually, not much time. So who has got questions? Yeah, you just ask one. You can go next. What?
Okay, so
Mhm.
I actually just similar to
Uh-huh.
So for when we are preparing the spare
Mhm.
for the emergency, so yesterday I know that it's 300, and how many spare drones we need to prepare?
Right. Yeah. So like it's come down like over time as we've made the system more and more reliable. I would say on average we're sending 5% spares to a show, and I actually think that that's a little conservative. But I'd rather be conservative. If we have 5% extra drones to send to a show, I'm going to send 5%, and it makes our pilots' lives a lot easier, so they're not stressed that like every single drone has to take off. Right? They have those spares to lean on if they absolutely need it. Yeah, so 5%. Yeah, so for every 100 drones, you have 5 drones of spares. I think you really only need like 2 or 3 to pretty much guarantee when you hit go, you have 100% of the drones healthy. Yeah, yeah, yeah.
I was just wondering, like, what's the primary cost of putting on drones? Is it the hardware? Is it logistics? Is it ground crew? Is it like what?
Kind of all the above. And a big piece of it is the design component, right? Somebody has to create it. So I think the market is anywhere from $200, $300 per drone up to $750 per drone is kind of what the market's asking for at the moment. And that if you're for the higher end portion of that, you're doing something much more complex, right? For the lower end market, what you're doing is leveraging a lot of designs that you've used in the past. So like that really brings the burden of the design down. Then there's just how many drones are you got. Like one of the key things that we've learned, especially with the current system, is like you pretty much want one person per 50 drones, and that's going to make people's life on site a lot easier. And that doesn't include the pilot. So if you go out and do a 200 drone show, you need a 5-person crew. So we'll send 2 of Verge people who are relatively expensive. That drives cost. And then try and hire 3 people locally to fill it out, right? So that's all cost there. The shipping isn't cheap, right? And logistics in this current moment aren't wonderful. So that's a big thing. Yeah, and then the price of the drones, the drones themselves, are more expensive than they will be in the future. And that's just as we're developing the technology, we'll be able to really miniaturize everything and bring the overall cost down. And I think when you combine all of those things, plus just a lot of automation around the logistics, the reporting, the fleet management, that means less time that we're spending in the warehouse pulling drones out to figure out which one's broken, and repairing it, right? So when you combine all of those different things, I think we'll be able to bring the price down. But the drivers are kind of like all the above, like all of the obvious stuff. The most unobvious thing is the design. It takes time, especially if you want a completely custom design. So that's a big factor in it. Yeah. Any other questions? Good. Cool. Yeah.
How much more what are the additional factors in getting like a moving image versus static images? Like, are you needing to worry about, is there any extra challenges there?
So let me rephrase.
A bunch of stuff that's moving in one line.
Yeah. Okay. So yeah, the question is about like how much more effort goes into these animated and moving designs. So like, I can only speak from experience of using our design software. So there's a lot of cues and a lot of things, like this flocking effect, for example. That's baked into our design studio, and that's all dynamic, right? Like this effect too. Like what we're doing is applying simple rotations to primitive, just a bunch of primitives. So like that rotation that you saw, or this one, that's just a sheet of drones, and then we apply a modifier to it and spin it, right? And to do that operation for the designer, that takes 2 minutes to do and then render, and you're like, oh, this looks cool. You can play around with the lights and all of that stuff. But it really depends. If you want to, there's an image in here where there's like a big flapping owl that was at EDC last year, and that was 600 drones. That specific design, that was all done with point clouds in an animation studio. So that effect was very expensive. But it was the keystone, it was the effect that the client wanted. Yeah, this one here. Like that took a lot of effort and really talented animators to do that. So it really depends on what you want. Like, what are you promising the client? How much effort do you need to put into these things? And what we're always trying to do is wrap as many tools into the designer to make stuff like that way easier. It's all about what you need. What the place that we need to get to is you don't need to be an engineer to operate the system. And I think we're already there. But there's definitely room for improvement. That's a lot of what goes into that. I hope that answers the question. Yeah. Yeah. Oh, yeah. You could. Yeah. Yeah. I think you next. Yeah.
There's some report like when we was TV, it was from the SD, HD for HD.
Mm-hmm.
Okay, like that.
Right.
Thinking, do we have the more draws and enclosures, and maybe some control will be more complicated.
Yeah.
How the progress will be happening?
So your question is then like how do we see the progress of going from these like smaller like more distributed effects where there's a lot of spacing to much tighter and complex formations. Yeah, so the way that I see that, so a lot of this you have to start automating. So like one of the ways, like this, that was done using a mesh. So what we can do is we can pull that mesh in, and then we can automatically assign the pixels in a way that makes sense and do that on an algorithmic basis. So like when we want to when we have 600 drones to play with and we want to do these very complex shapes, it's all about creating the tools to pull in an animated mesh from a 3D design software, and then how do you automatically put the points on there so you're not individually placing the vertices of that mesh, and a lot of automation around that. So I think that'll help out a lot. Another thing that's super key is that like our drone is pretty big. It's like the size of a DJI Phantom. It's like on that scale. For us, that drone needs to become a lot smaller. Once we have a smaller drone, then we can really start to bring in, reduce the spacing between the drones, and that will allow us to take that 3D effect that's animated, automatically assign drones, and put them into a much tighter formation. We can do that today, but we tend to not do that just because you need more pixels, and really, right now the market, like I said, is like 200, 250. Some of the higher end clients will do like 400, 500, 600 drones, but that's more rare. It's about building that tooling into our design software to make it really, really easy so you can increase the resolution of the individual effects. That's the way I look at it, at least. Yeah. Yeah.
Yeah, so obviously put a lot of time into stuff. How much lumina are each of these nodes?
1,000 lumens per, if you have all 4 dyes. So we have RGBW. If all 4 dyes are illuminated, yeah, it's 1,000 lumens. We put it through some mixers as well. So like you'll just take a generic hex code, that'll get translated into RGB space. So you'll change the space, and then on the driver side of our of the LEDs itself, we're applying a bunch of transformations to make sure all the colors are matched. I would say that for any given color, the average luminance out of it is probably going to be on the order of like 400 lumens. But so because you can only leverage so many of the dyes at once.
So what kind of fight time do you get with because
Mhm.
about the size of the fan.
Yeah.
So same battery size, or did you enhance?
Similar battery size. I think it's a little bit smaller. It doesn't matter. It'll hover for 20 minutes easily. Yeah, and then so we published like 15 minutes. One of the problems with this drone and a lot of the other drones just currently in the market is like once you plug the battery in, it's going to start drawing power. So the future of this is the drone by default needs to be in a low power state where just lower the clock, only query like only activate the GPS, and like there'll be different stages of it. So and then also like remotely, the pilot can put everything out. They can in one step activate all GPS, so they start collecting GPS data, start getting that RTK solution that you need, and then 5 minutes before the show, you hit okay, all sensors on, right, and now it goes into high power mode and it's ready to go. So that's a future piece of the technology that just hasn't yet been developed.
More cool practical than I see the fireworks.
Right.
So the fireworks are highly unpredictable. How do you do for standoff? Like,
Ha.
rockets go up.
Oh yeah. Luckily we haven't had a collision with a projectile yet. I bet it'll happen. We actually haven't hit a bird yet either. All of those things are inevitable. But yeah, now usually when we're working with fireworks, which we actually do a lot. And by the way, a drone show with fireworks, especially when they've been synchronized, it's beautiful. Talk about taking fireworks to the next level. What we end up doing is like you fly a nice shape, and then when the drones are transitioning and moving to the next shape, you fire a bunch of fireworks and keep that going. And just that rhythm, back and forth and back and forth, the interplay between the two entertainment technologies is absolutely gorgeous. It's mind-blowing. So yeah, it's pretty much just like you generally know where the shells are. And the fireworks companies, they know where their shell, like what the safety radii are. So we'll just make sure that we're out of it. We're usually in front of them.
Like a half mile, like approximately how far
Oh, the drones themselves?
from the fireworks?
Oh, from the fireworks, like your typical show is going to have like 400, like 4-inch shells, which will go like 400 feet. Some will have like 5-inch shells, which is like 500 feet. And then the blast radius is essentially 1-to-1. So, we can get comfortable. We could be like 70% into that. So for a 4-inch shell at 400 feet, we can be like, 250, 300 feet away, and it's not gonna result in anything bad. Yeah, but yeah, we're not flying over where the projectiles are. No, yeah. Yeah, we actually had a situation a couple of weeks ago we did an EDC again. We flew like 15 shows in Vegas, and somebody didn't tell the fireworks company to not fire their fireworks while we were going out, and we flew over where their rigs were. And like the drones just flew over, and then this is a electric music festival. The bass drops and fireworks go up. And we're like, "What the hell? No! Get on the radio! It's like, tell them to stop now!" So, yeah, there's a lot of that, miscommunications and stuff. But that's kind of just the nature of the beast. Haven't had any. It's just those types of safety distances are important. Yeah, in the back. Yeah, so that's a great question. Our network is set up so the drones actually can talk to each other, and it could even be formed into a mesh network. But for this use case, it's completely unnecessary. The network ends up getting it ends up being a star network where the ground station is just round robin querying the drones, and that's how we keep essentially time slicing the time between the drones, right? But yeah, the drones, when they're flying, they think they're the only drone flying. They have no idea. They actually do have the information on board to know where the other drones are, but we're not processing that in real time and not making any decisions on that in real time.
And the whole time they're connected to the base station.
The whole time they're connected to the base station, so live you can see the entire show. Yeah.
Hey.
Uh-huh. Uh-huh. Yeah, that's a good question. Yeah, we ended up, we thought you'd think that GPS time would have been the best. We actually saw a lot of variability from that, and I think that's just from the rate that we're querying the GPS for its latest, we're querying it, we're getting 5 hertz position updates. So it was actually more efficient for us to just send out and broadcast time synchronization while they're on the ground. Once everything's synced up, which we have like some simple visual checks to make sure all the drones are synced up. Yeah, we just end up doing it from the ground station.
I'm sorry, but we just run out of time.
Oh, okay.
But Tony's going to be here and also in the after party.
Yeah.
All right. Well, thank you, Tony, for your time.
Thank you.